All right, my friends, in this video lesson, we're going to take a look at double displacement reactions, which is our fifth and final of our reaction types for this unit. So first of all, what is our general pattern? We have AB plus CD making CB plus AD, okay? So what does that mean to us? Well, we need to start off as our reactants, two ionic compounds. So we first of all see copper 2 nitrate as one ionic compound and sodium hydroxide as our second ionic compound, both in solution. So we really have a bunch of ions floating around in water. Okay, they're going to produce products, which is basically going to be a trading of the metal partners. So our A and our C essentially are just going to trade places here to make two new compounds, sodium nitrate and copper 2 hydroxide. Okay, it's worth noting here that there will be different subscripts based off of the ionic charges, and we definitely want to balance this chemical equation also. It's also worth noting that this solid formation here is very important to us as we look further into this reaction type. So for this reaction to actually happen, for us to actually get chemistry here going on, we need to make new bonds. We need to break things, we need to form things, we need electrons to transfer, we need to see some of that stuff happening. So the way that we can identify that, or we know that's going on, is through one of three possibilities. First is that precipitate formation. And again, that term precipitate, we have learned before, it just means that there is a solid that forms from solutions being combined together. So in this case here, we do see that, where we have a precipitate forming, so this chemistry would happen. Second thing, we can make water. That would happen in a neutralization reaction, which is a topic for our future unit on acid-base chemistry. And then there is a case where you can make gases. It's fairly rare, but this does happen also, okay? In all three cases, this is basically driving the reaction forward because we are creating new chemical bonds, and that is a necessity to make this happen. Now, we're going to do a little bit of practice here, and we're going to move pretty quick through this because this is not a real video, and I don't have time to, as I would spend with my normal students. So here we go. Here's our first example. We have lead 2 nitrate reacting with sodium iodide, and they're going to trade partners again, and that would make our sodium nitrate and our lead iodide. We know this reaction will happen because we form that precipitate, or that solid is forming here with our lead 2 iodide. We would want to balance the equation and make sure our ionic charges are correct also. Our second example would be potassium chloride. It would be reacting with magnesium sulfate, and when they react together, we would find them, but then we would notice when we check our solubility chart that the magnesium chloride and the potassium sulfate that are formed here stay in solution, and because they all in solution, it's basically a bunch of ions floating around with a bunch of ions and no new bonds are forming, that we would get no reaction here in this process. So it'd just be a big mixture of stuff. Finally, we would have the example of sodium hydroxide reacting with hydrochloric acid. Again, when they mix together, we would get this kind of weird chemical HOH, which then hopefully we could identify that that is just water, or is our H2O, when the hydrogen switches places with the sodium. And because we're producing water, this reaction would also happen, okay? Now, that's a very quick mini lesson that obviously would be much slower if I was working with my students. Thank you.